Hey everyone, wanted to continue our our looks at word problems and quadratics. So we looked at a couple of rectangle examples, and then we looked at a triangle example, and right now we're going to look at an example of an area of a circle. If we remember, the formula for the area of a circle is pi r squared. Now, I know sometimes we get a little bit confused, about pi because we treat it as a variable, but it is a real actual number. So it's kind of strange. So it's really like a constant. So when the diameter or the radius changes, then the area of the circle is going to change. So we're going to investigate how that's going to work. So in this situation, we have a circle and a picture, which is really nice because I can't draw circles. So we know that the area of the shaded region, so that's this region, the ring, the gray ring that goes around, the area of that is 56 pi square inches. And they want us to find out what the width of that region is. So we kind of need to assign a variable. For that, well, they give us a really nice hint, and they say we should call it x. So can't argue with that. I'm going to call it x. I'm going to use this a little slightly bigger. So how did they get the area of that shaded space? Well, you know what they did was they took the area of the whole thing, so of the whole thing, including the shaded space, and then they took the area of the not shaded part, which is the inside, and subtracted. So it's kind of like they took the area of a donut hole and took the area of a full donut, kind of like, it's a jelly-filled donut, and then they subtracted the hole from the jelly-filled, and then they came up with a traditional donut. So we're going to do the same thing. We need to find out the area of the whole donut, the jelly-filled donut. So for that, we need to know the radius. Well, our radius there is going to be 5 inches plus x. So the radius, the area of the small circle, I'm sorry, I misspoke. The area of the large circle is going to be pi times the radius squared, 5 plus x squared. I probably should write that as x plus 5. And I probably will. Then we need to subtract out the area of the white circle that has a radius of 5. So that's going to be, the area of that is pi times 5 squared. So this is basically all we have to figure out. And then we know that that's going to equal 56 pi. Now, what's really nice is we don't have to really let pi freak us out, because there's a common factor everywhere of pi. So we can divide everything there by pi, and then they all go away. So then we're left with, I'm going to write it this way, x plus 5 squared minus 5 squared equals 56. So now we just have to square this, and if you remember the pattern for squaring a binomial, it's the first term squared plus 2 times the product of the two terms plus the last term squared. So it's going to be x squared plus 10x plus 25. Now we're up to here, this part, minus 25. Kind of convenient. Equals 56. So let's do some simplifying. X squared plus 10x equals 56. Well, we're in a place where we could actually complete the square. I don't know that it's going to be, if we bring the 56 over, I don't know that it's going to be easily factorable. Factors of 56, I don't know, 2 and 28, not 3, 4 and 14. Well, that's actually going to work. So we could do it with factoring. But you know what? Let's not. Let's complete the square for this one. So, because it's not, so we'll say it's not easily factorable. So is B an even number? Yeah, it sure is, because it's positive 10. So we're going to complete the square. Now what I'm going to do is I'm going to move some of this, whoops, I always do that. Move some of this over so I can create that blank space. So I'm just going to move these kind of things over. Well, maybe not. I guess I'll have to erase them. Okay. So, equals 56. So, completing the square is the halve it, cut it in half, square it, and then add it. So what I'm going to do here, half of 10 is 5, and 5 squared is 25. I'm kind of just going to write this as 5 squared here. That's going to help me with finding out what is being squared. And then I also have to add it on the other side as well. So, this should look hopefully a little bit familiar. X squared plus 10x plus 25. Well, that's just exactly what we had up here. So this is actually the same thing. X plus 5 squared equals 56 plus 25 equals 81. Like that. So we've completed the square. Now we just need to take the square root of both sides. Square root of x squared plus 5 squared equals plus or minus the square root of 81. So the square root undoes the square, so that's really nice. We can say x plus 5 equals plus or minus 9. Then if we subtract 5 from both sides, we will get negative 5 plus or minus 9. So this is supposed to be the width of that gray area. So let's take a look at these here. Since we have a plus or minus situation, we kind of got to look at both of them. So x could equal negative 5 plus 9, or, there we go, or x could equal negative 5 minus 9. So negative 5 plus 9, that's going to equal 4. And negative 5 minus 9, that's negative 14. So we're looking at a distance, a length, a width, which can never be negative. So we have to ignore that answer. So we can say that the width of the shaded region is 4 inches. Now let's just kind of check this out and make sure it works. So we're going to take the area of this circle that now has a 9-inch radius. I'm probably going to yeah, I need more space. Okay, so So I'm going to take this 9-inch radius circle. So that's going to be pi times 9 squared minus pi times 5 squared. And we're going to hope that that's going to equal 56 pi. So let's see. 9 squared is 81, so that's 81 pi minus 25 pi. 81 minus 25 is 56. So it works out. So that shaded area has a width of 4 inches. And so it's like we're taking things apart and putting them back together. So that's our example for a circle. And I believe that the question on the quiz will be very, very, very similar to this. So we have a couple more examples to look at, and I'm going to make a separate recording for each one. So I'll be back shortly.